A few more problems for Gibbs free energy. The first question is this reaction spontaneous at room temperature? Now this is a solid that is trying to become into a gas, so you need energy to do that. You need to heat it up. It's endothermic, that makes sense. But since you're going from solid and you're producing 1 mole of gas, your entropy change should be positive. So it's positive, endothermic, nature doesn't like it. Delta S is positive, nature likes that. So let's calculate delta S first, which is sum of S's of products minus S's of reactants. And then we have 213.6 plus 39.7. That's my products, minus 92.9. And when we do this, we get 160.4 joules per mole per Kelvin. By now you know you should divide by 1000 to convert it immediately to kilojoules per mole per Kelvin. Then let's just plug it in and see if that's spontaneous at room temperature. So delta H is 178.3 minus 298 Kelvin times 0.1604. Negative times minus is a negative quantity. We wanted this to be bigger than this. Unfortunately, at room temperature, it's not. And it gives you positive 130.2 kilojoule per mole. So first answer is no, it's non-spontaneous at room temperature at 25 degrees Celsius. Now let's just change the temperature to what they're asking us. Add 273 immediately to this, so you get 1575 Kelvin. Let's calculate delta G now. Temperature has increased, so this quantity gets larger, and hopefully it's a larger negative number. So it's positive 178.3, that's your delta H, minus 1575 Kelvin times 0.1604. When we do this, we get negative 74.6 kilojoule per mole, and the negative is indication yes, it's spontaneous at this temperature, at this elevated temperature, equals 1575 Kelvin. The next question, this time I'm not giving you delta H of reaction, we rather have to calculate it. So remember that when formation is given to you, and elements by definition have delta H formation of 0. So delta H of reaction is simply sum of enthalpy of products minus sum of enthalpy of formation of reactants. So there is a formation of product here. So we have 2 nitrogen dioxide, so 2 times 33.2 minus 2 times 90.2. And when we do this, we get negative 114 kilojoule per mole. Delta S of the reaction has the same sort of calculation. It's sum of S's of products minus S standard of reactants. Now this time remember that we have entropy for elements. We can actually calculate that. We don't have delta H formation because they have been formed, but they have a disorder or randomness into them. So this is equal to 2 times 240 plus 102.5 for oxygen minus 2 times 210.7. When we do this, we get negative 43.9 joules per mole per Kelvin. Divide by 1000, so we have negative 0.0439 kilojoule per mole per Kelvin. Now let's just plug it into delta G equals delta H minus T delta S. Now our delta H is exo, nature likes that, but we are becoming ordered, and because you're going from 3 particles of gas to 2, and this is a negative value. Negative times negative is positive. We are hoping this is smaller than delta H. So when we plug it in, we get minus 114 minus 298 room temperature in Kelvin times minus 0.0439, and you definitely get a negative 100.9 kilojoule per mole. So this is indication that we are spontaneous at room temperature for this reaction. The last problem I do for this series is just to tell you, if you have delta G formation information, use that. But also, same definition applies to elements. They don't have delta G of formation. So if you have a reaction, you really don't need delta H and delta S. If you have delta G formation, just apply it into this equation, which is same as delta H and delta S. So delta G for this reaction is 2 sulfur trioxide, 2 times minus 370. That's my product, minus my reactants, which I have 2 sulfur dioxide, 2 times negative 300, plus I add it at 0 to just indicate that delta G formation of elements are 0 by definition. They have been already formed. And when we do this, we get negative 140 kilojoules per mole. So simple to solve if we have delta G formation. And once you get the negative, just say it's spontaneous because of the negative sign. So you have this much free energy to do useful work in this reaction.